Hello everyone, welcome to my YouTube channel Know About Embedded Systems. So in today's video we will understand what are the different errors which are available in the CAN and CAN networks. So this is going to be one of the important video for your interviews. Please watch the video till the end and gain the knowledge. So before starting the video, if you're a new viewer to my channel, kindly subscribe my YouTube channel and gain the knowledge. So guys, in the previous video I have explained you what is the CAN, what are the properties or characteristics of the CAN, what is the frame format. All those things I have explained, and today we will discuss one of the important topic that's called as an errors. There are totally five types of errors you can find in our CAN network. They are named like this. One is a bit error, stuff error, form error, acknowledgement error, and CRC error. So because of these five errors, we're able to identify what type of error occurred in the network and how to take the precautionary measures and how to react to the CAN network. So that part we will discuss in today's video. Let us start the video. The first one, bit error. What do you mean by bit error? So bit error means, let us see the waveform diagram and explanation. See guys, whenever any ECU or any node transmits any data, any bit of data, the same bit will be reflected back. So for example, if I have a node here, so this nothing but ECU here. So when you transmit any data now, the same status will be reflected back. The same bits will be reflected back. Okay, now you can see here. So I have a transmitted bits here. The ECU is transmitting something called 101101 and it is monitored as 101100. So try to understand here. So it is transmitting 101101 and it is monitored from the CAN bus as 1011. There is a difference of 1 bit here. This is called as bit error. Bit error means whenever you are transmitting the recessive bit or dominant bit, the status should be reflected back from your canvas. If there is a discrepancy, if there is any difference, then that situation is called as a bit error, and CAN automatically flags this error, or it's going to indicate that there is a bit error. So now you can see here every CAN node in the CAN it's going to be monitor the signal level of any given bit. If there is any difference, if you observe here, the same status or a bit status will be read back to the same transmitter. If the transmitter is transmitted as a dominant or a recessive, and if it is getting a different bits status from the CAN bus, then that is going to be called as bit error. So bit error means the same bit you should get when you transmit, or the same status will be reflected back. If there is any difference, then that is going to be called as a bit error. The second one is called as a stuff error. This stuff error, let us understand with one example here. So guys, you might be already knowing what is a bit stuffing. In my previous video I have explained in detail about bit stuffing. The bit stuffing is used for node synchronizations, and it's going to ensure all the nodes to be synchronized in a proper way. So we are going to insert something called as bit stuffing, and whenever you're transmitting more than 5 bits of the same polarity. Example, if you see here, I'm transmitting number of zeros and number of ones here, more than 5. So the bit stuffing means every 5 bits of same polarity, when you're transmitting, the opposite polarity bit will be added. This is applicable for zeros and ones as well. So this is a normal way, so where you will be transmitting with a bit stuffing. But in another case, if you observe here, in the second use case, I am transmitting same bits without bit stuffing. The same bits will be transmitted with zeros. You can see there are more number of zeros are there, more than 5. Here also more than 5 number of ones are there. So whenever you're not applying a bit stuffing, whenever your CAN controller is not able to apply the bit stuffing, then that is called a bit stuffing error. Okay, so this bit stuffing error is observed usually in the receiver side whenever there is no bit stuffing in your transmitted bits. Okay, now you can see the bit stuffing is a part of CAN standard protocol. It is going to add a dedicated, it's going to dictates for every 5 consecutive bits of the same polarity bit, the sixth bit is going to be a complement. That means whenever you're transmitting five consecutive number of ones or 5 consecutive number of zeros, the sixth bit is going to be complement of that. You can see here, this is called a bit stuffed bit. So why this is required? This is required to keep all the nodes in the synchronization way, in a proper synchronized way, and also it is going to provide, or it's going to ensure the misinterpretation of data. It avoids the misinterpretation of data. So for these two major reasons, we are going to use a bit stuffing in our CAN protocol. So whenever bit stuffing is missed, whenever you have more than 5 bits of data of same polarity, whenever there is no bit stuffing, the bit stuff error will happen. Now you can see the next point here. If a sequence of 6 bits of the same logical level is observed on the CAN bus, that means you should not have 6 bits of the same polarity. This is not allowed. You should allow only up to 5 bits of same polarity, and as soon 5 bits are completed, the next bit should be a one opposite polarity bit. Then that is called as a bit stuffing. So if the sequence of 6 bits with the same polarity, try to understand the statement here, the same logical level is observed on the CAN bus, then that is called as bit stuffing error. So in that situation, the receiver is going to be detected with a bit stuffing error. The next error is called as form error. What do you mean by form error? The form error means in our CAN frame, there are very specific bits are defined with a specific levels. If you consider, let us assume this is my frame here, there are very important fields with a specific logical levels. You can see here, this is a logical one, logical level, this is a start of frame. So this start of frame, always it should be 0. Okay, the start of frame, always it should be 0. And acknowledgement delimiter should be always 1. CRC delimiter, always it should be 1. And end of frames, always it should be 7 recessive bits. Like this, in our CAN frame structure, they have, in the CAN protocol, they have already defined the standards logical levels for specific fields such as start of frame, delimiters, delimiters, and end of frame. These should have a specific logical level with a specific numbers. Start of frame should be 0, acknowledgement delimiter should be 1, CRC delimiter should be 1, and end of frame should have 7 number of recessive bits. Whenever you are going to violate this structure, then that situation is called as a form error. Now let us see the definition here. The CAN message must always be with some certain levels, or certain logical levels, specifically 1 bit for start of frame, and it should be dominant bit. You can see here the one specific bit, it should be a dominant, and that should be a start of frame. Then we should have 7 end of frame bits of recessive. Then acknowledgement and CRC delimiter should be recessive, that means logical 1. If there is any deviation of these fields, if instead of start of frame, instead of 0, if you get 1, then that is called as a form error. CRC delimiter, instead of 1, if it is getting 0, then this is called as a form error. Okay, so I hope you are clear now. Then we have an acknowledgement error. So what do you mean by acknowledgement error? So we have to consider 2 scenarios here. So this is in a transmitter side. Usually from that, when you transmit any data, whenever you transmit any data, the transmitter will transmit acknowledgement field with a recessive bit. You can see here, this is my transmitter side. From the transmitter side, acknowledgement bit will be recessive when you are transmitting data. But in case of when you receive the data in the receiver side, that acknowledgement you need to modify as a logical low. So that means you have to send a logical active low signal or a logical 0 signal to the transmitter saying that there is a successful reception happened. Okay, so whenever there is a mismatch, whenever your receiver is failed to send an acknowledgement as a 0 to the transmitter, then that situation is called as an acknowledgement error. Whenever there is a missing of acknowledgement bit in the CAN frame, then that is called as acknowledgement error. Now you can see here, whenever transmitter transmits a CAN message, it will contain acknowledgement field. That means this field. So in which the transmitter will transmit as a recessive bit. This is what I told. So here the transmitter will be transmitting as a recessive bit, that nothing but 1. So all listening nodes, nothing but all receivers, are expected to send a dominant bit to the same field to acknowledge that data has been successfully received. Okay, the receiver supposed to be send a dominant bit to verify that reception of a message has been successful. If transmitter does not read a dominant bit on the acknowledgement slot, then the transmitter detects as a acknowledgement error. So that means this bit should be 0 when you are after transmitting your data. Okay, so I hope they were clear. Then we have CRC error. So what do you mean by CRC error? So now let us consider one frame here. I have one frame here like this, and in this frame we will have one important field that's called as CRC. CRC stands for Cyclic Redundancy Code or Cyclic Redundancy Check we will call. So this is a 15-bit data. The 15-bit data we are going to transmit here in the CRC field. There will be some mechanism, there will be some calculation logic will be there. Using that logic we will be adding the CRC field with a 15-bit value. Now let us consider here the received whenever you receive any data, let us assume, so received data or received CRC is 1024. Let us assume this is a received CRC, and also there will be mechanism to calculate the CRC in the receiver separately. There will be two things, one received CRC and one more is calculated CRC in the receiver side. So two things we have to consider, received CRC from the frame, and second one is calculated CRC in the receiver. Separate logic is there to calculate the CRC in the receiver side. So whenever both are matching, so you can see here the received CRC is 1024 and calculated CRC is 1024. So whenever you are receiving a proper value or both same value, then I will say that there is no error or there is no any CRC error. Okay, and then I have one more use case here. If you observe in this use case, received CRC is 1024, but in the calculated CRC I'm getting as 1055. So here both are not matching. The received CRC is 1024, calculated CRC in the receiver side is 1055. So since both are not matching, then the CRC error is going to be detected in the receiver side. Okay, I hope you are clear. Now let us see the definition here. Every CAN message contains a cyclic redundancy check of 15 bits. That means this field. Here, the transmitter has to calculate the CRC value and add it to the message. That means from the transmitter side, the CRC will be calculated and it is going to be added in the frame. Every receiving node will also calculate CRC on their own. You can see the second point. The receiver will also calculate the CRC by its own. If the receiver CRC calculation does not match with the transmitter CRC, then receiver is going to be detected as CRC error. Okay, so like this, the CAN is having its own error identification mechanism with a different scenario. Based on this errors, we are going to take some precautions, and also we are going to send some warning messages to the different ACUs which are available in the CAN network. I hope this video is an informative video. If you feel this video is an informative video, please click on like button, share to your friends, and subscribe my YouTube channel.